Alright, so I have never done this before, and I'm probably going to make a fool of myself attempting to do this, but I'm going to record myself going over how to do ray diagrams for mirrors. If all you are here to get is the final answers, I'm going to upload these pages that I'm filling out as PDFs, so there's no reason to watch me awkwardly muddle through them if that's all you want. But ray diagrams, it's usually a lot easier to learn by watching someone else. Okay, so the trick to solving ray diagrams is these 3 rules. And basically when you start out, you just have to memorize them. There's no getting around it. But once you've worked several, it becomes fairly intuitive what rays you need to draw. So let's go through the rules first. So they've given us the first half of each rule. This half is what the incident ray, so the light coming in, is going to follow what they've given us. And then what we have to fill in is what the ray of light is going to do after it hits the mirror. For the rest of this sheet and for anything else I do about mirrors, I'm going to color code. So blue is going to be for the incident ray, so this is light coming in, and red is going to be for the reflected ray. So the first rule tells us that we draw our first incident ray parallel to the principal axis, and it is reflected through the focal point. So again, the blue half of the rule tells us about the incident ray, the red half of the rule tells us about the reflected ray. Rule 2 is basically the opposite of Rule 1. The incident ray is drawn through the focal point, and then it is reflected back parallel to the principal axis. The third rule is probably the strangest. The third rule says that you're going to draw an incident ray along a secondary axis. Don't worry about secondary axis. If I was going to rewrite this, I would write it as you draw an incident ray through the center of curvature. Which we denote as C. And it is reflected back through the center of curvature. So basically back along the same original path. Oh, and I'm using the wrong color, look at that. Back through. That one's kind of weird, but once we do an example, you'll see what I'm talking about. So back through the center of curvature. And this is because the angle of incidence is 0. So back when we talked about the law of reflection, if it comes in at a 20-degree angle, it goes out at a 20-degree angle. If it comes in at a 0-degree angle, then it goes back out at a 0-degree angle, which means that it would go back along its original path. All right, well, let's try working one of these, and I think it's going to make a lot more sense once we do. So here they have told us, which is nice of them, they've told us up front that we're dealing with a concave mirror. This is the mirror, that's semicircle. This thing here is the object, so this is you. You are looking into your mirror. I don't know why you would be looking into a concave mirror, but you are. And what we're going to do is we're going to follow these 3 steps to see what it is you would see looking into that mirror. All right, so we're going to start by drawing our first incident ray. And our first incident ray should be drawn parallel to the principal axis. So that's going to look like this. All right, and we know that that ray will be reflected through the focal point. And that's actually not a great job. You want to get as close as you can to passing right through whatever it tells you. It'll probably turn out okay. I'm too lazy to start over, so. Our second incident ray is the opposite. It goes through the focal point. Incident ray. Let's label our rays, actually. So this was 1, incident ray 1, reflected ray 1. incident ray 2, and our reflected ray 2 is just going to be parallel to the principal axis. So that's reflected ray 2. And see, this isn't going to turn out quite right, which is probably because of my mistake up here. But I think we'll still get the point across. The last ray is supposed to go through the center of curvature. So our incident ray goes through the center of... Oh, my pen didn't write. Okay. The incident ray goes through the center of curvature. And now I'm just all kinds of screwed up. Maybe I will start over. The incident ray goes through the center of curvature, in theory. Let's make our center of curvature huge so I can pretend that I did this well. And here's the tricky part. This is the one that gets reflected back along the same path. So that means that the reflected ray looks like that. So here was our incident ray 3, there was our reflected ray 3. Now, here is where our image is formed. So we started at the tip of our object, so this intersection is also the tip of our object. So here is what our image looks like. Alright, once we get to this point, there are a variety of things that we can say about this image. For one thing, it's going to be a real image and not a virtual image. We know this because of the side of the mirror that it appeared on. It's in front of the mirror. If it was behind the mirror, maybe I should, make sure you guys can see what I'm doing now. So in front of mirror is real. It's also an inverted image. And I drew it inverted, but I knew to draw it inverted because our intersection happened below the axis. If our intersection had happened up here above the axis, that would be an upright image. Finally, if you look at the size between our original object arrow and our image arrow, you will see that it is reduced in size. So those are the three things that can be said about this image for the concave mirror.